So, to start with for today, since it's our final math class, I'm going to give you about 4 or 5 minutes to grab any questions you have at all. And if you want to play Stump the Teacher and come up with the most difficult diabolical problem you can come up with, I will take it. I don't guarantee I'll get it right, but I'll take it. And if not, these are the ones that I have in mind as this is something that I think we should talk about and it might be useful to you. So we will go from there.
Is this for a specific test? Or?
No, from any ones that you have taken. I specifically am aiming towards the first three because those are the ones that caught my attention, but anything that you have done for homework or in class testing is fair game. All right, we'll go ahead and start with online first, just for clarity. What questions do you have for me, if any? right.
57 on page 494.
494. Ah, I meant math.
I thought this was math.
Oh, do I have the wrong book again? Hold on a second. I always forget that I've got the wrong one. Glad we caught that early this time. I'm gonna make 490. You said 497?
494.
494. Okay. 57. Okay, so we've got. Oh, I looked at this one. Well, it's one similar to this one. So vectors A, B, and CD are shown in the standard x, y coordinate plane below. One of the following is the unit vector notation of the vector A, B, and CD. Which one? Or sorry, AB plus CD. Which one? So unit vector notation is going to be going back to the idea of x and y. X obviously comes first, is the I, and y is the j. So, looking at AB first, how far over, how far up?
Over and
I'm getting 9.
hold on. I just need to. Oh yeah.
So our first vector has 9 over and 6 up?
Yep.
And so as a vector, this is 9i plus 6j. Our second vector, is it going over at all? No. And so that would be 0i. And our second vector vertical change is 5. And it's just adding components. 9 plus 0 is 9. 6 plus 5 is 11. And so it would be E, that 9i plus 11j. And so it's just, as a component, this far over, this far up. This is not over at all, but this far up. If you had ones going down or to the left, those would be treated as negative numbers. But that's what's going on there. Good question. Well, unfortunately all my preparation is going to be on problems you don't have, so I will have to go a little bit slower. If anybody else has any other questions, I do not mind at all. All right. So, I've talked about this before, but I'm going to keep hammering it because to me, number sense is the number one category. When I go through this and try to say, oh, this is a trig problem, this is a geometry problem, this is a algebra problem, a lot of them it's like, this is a number sense problem. It's asking, are you comfortable and confident with numbers and what it means? And so the more familiar and comfortable I can get you with that, the better off your tests will be. And so this one starts pretty easy. It says, what's the smallest integer greater than, and it's going to be greater than the square root of 85. Two ways to do this. You can run it through the calculator, or you can be familiar with your perfect squares. Both of them are okay. So, if you want to go for the calculator route, what is the square root of 85?
9.21.
Okay, so what is the next integer that is greater than that? All right, vocabulary, what's an integer?
Number.
It's a number. What kind of number? Is 9.25 an integer?
No.
No. So integers are the counting numbers, both positive and negative. So if this is 9.2 something, the next integer greater than that is going to be go up to 10. And that would be our next greatest integer. Other way to look at it is, okay, perfect squares, 81 would be 9, so 85 is too big, go next up, it's 10. All right, next one, it says, for every pair of real numbers, x and y, such that x times y is equal to 0, and x divided by y also equals 0, which of the following statements is true? So we're told the two numbers together multiply equals 0, and the two numbers divided, x divided by y, also equals 0. So, is it true that x equals 0 and y equals 0?
No.
No. That would be causing a divide by 0 error there. That one is out. Is it true that x can't equal 0 and y does equal 0? No.
No.
Same flaw there. We'd get a divide by 0 error. Is it true that x equals 0 and y doesn't equal 0? Yeah, because one of these has to be 0 in order to multiply to 0, and this one definitely cannot be because it causes that error, and so our answer would be C. The third one is that neither one equals 0, then this one would fail, and none of the above statements are true is our final option, but that C did work. All right. So, again, they like throwing numbers A and B at you. And you can always try to put in some values if you are needing it, but that's what we're doing. So we have A is bigger than 0, and B is smaller than 0. And which of the following is equivalent to the absolute value of A minus the absolute value of B? The options they give us are dying marker, absolute value of A minus B, absolute value of a plus b, absolute value of a plus the absolute value of b, a minus b, no absolute value, or a plus b. So, given these boundaries, a has to be greater than 0, b has to be less than 0. Which one of those is true? Can you see all right? Yeah, it's showing up okay. Again, you've got two options. You can either work on it through the number sense angle and try and do it for all numbers, or you can pick a value for a and b and check. Number bigger than 0, 1. Number smaller than 0, -1. Absolute value of 1 is still 1. Absolute value of -1 is 1. 1 minus 1 is 0. Which one of those will give us that answer?
C.
Absolute value of 1 is 1. Absolute value of -1 is 1. 1 plus 1,
Oh.
no go.
Oops. BP.
That one does work. So, let's try different numbers because this one is also working, and so I'm not sure which one. It's good to check, but it's also good to double check. So let's pick -2 here. If I took absolute value of 1 is that, minus absolute value of 2 is this, we get -1. And so that one would be it, because I can force it to get a negative number and there's no way to get a negative from there. So that is the good thing to point out. Testing numbers is good, but as long as it works for this one, keep going that there's another one it works for, and then figure out which one you can break it on. So, very good thing. All right. Next one. So we have x is less than y. And y is less than 4. What is the greatest possible integer value of x plus y? The options they give us are 0, 3, 4, 7, or 8.
I think it's 3.
I think it's 3. Okay. What value were you picking for y? Because remember, we're talking about the sum of these two numbers.
Oh, I thought we were just trying to
Yeah,
find this.
it's all right. So, on these, I would start at the bottom and work up. We know that y is less than 4 and x is less than y. And so we could write this as x is less than y is less than 4. Kind of in a line here. Is there any way possible for the two of them to add up to 8? No, because y is less than 4 and x is smaller still. No possible way to get to 8. That one's out. How about 7? This is an interesting one. The trick is they ask for the sum to be the greatest possible integer. Do x and y have to be integers? No. Like, think about it, if you have 1/2 plus 1/2, it equals 1. And so these pieces don't have to be
Numbers.
whole numbers. And so if we have x plus y equals 7, this could be 6.9. And this one could be 0.1. And it still equals 7. And so there's no way to get to 8, but 7 is definitely possible. There's a lot of different combinations you could come up with 7. Oh, no, I'm wrong. Sorry. I jumped the gun. I forgot the boundary of 4. So, 3.9. And this one would be 2.1. So, the idea is you can stagger them and still get to 7. I'm going to skip that one. So I ran across this in 2 separate tests I looked at. I know you guys have done the first test, I'm assuming, in the book, but never mind, you didn't have the same book as I did, so that doesn't work. Have you run across the word abundant before?
So, I think on another test, probably.
It's probably on this test. This is one of the weird places I hadn't seen it before, so it's worth talking about. It says an integer is abundant if its positive integer factors, excluding the integer itself, have a sum that is greater than the integer. So the idea is, given a number, all factors of x except x that add up to more than x. And so they give us the options of 6, 8, 10, and 12 and ask how many of them are abundant. And so multiple choice, they either have 0, 1, 2, 3, or 4. As in, none of them, all of them, somewhere in between. So, what are the factors of 6?
2, 3.
2 and 3 but also 1 and 6. And so that 1 comes into play, just to be aware of it. So we say all the factors except that. So we have 1 plus 2 plus 3 is 6, but that's not more than. And so 6 is out. For 8, what are our factors of 8? 1, 2, 4, 8. We throw out 8. 1 plus 2 plus 4 is 7. Not more. For 10, we have 1, 2, 5, and 10. That's out. Again, not enough. For 12, we have 1, 2, 3, 4, 6, and a 12. So we take out the 12. 1 plus 2 is 3 plus 3, 6 plus 4, 10 plus 6, 16. And so this one, yes, and we'd say one of them was. This is basically the mathematical definition of divisible by lots of things. And so they are looking at the opposite of prime. Abundant numbers can be very nice to work with. One of the most famous ones, 60. 60 is very useful, which is why our time is based that. In circles. All right. So, big chunk of book. There's lots of spelled out answers on this one. All right. So, this one harkens back to that first one again. It's not hard, but it's just a case of understanding what they are asking for. It says the square root of a certain number is approximately 9.2371. So this equals a certain number square rooted. The certain number is between what two integers? So x is in between an integer and another integer. What window are we looking at? So, the options they give are 3 and 4, 4 and 5, 9 and 10, 18 and 19, or 81 and 99.
I've got my answers nailed down, but I don't know. You said integers specifically?
Yes.
So 9 and 10. No? Was it 81 and 99?
It's the 81 and 99. Because remember, it tells us that the square root of our certain number is here. And so that's why I wanted to talk about this one, because it is tricky. It's going on of, okay, this is the square root of our certain number. Where would this number be by itself? And so you can square both sides if you want to look at it that way and cancel the square root. Or you can say, okay, use that 9 and 10. 9 squared is 81, 10 squared is 100, and you can get the window that way. will never object to a mistake where you tried it. Never. All right. All right. For a math homework assignment, go figure, Carla found the area and perimeter of a room of her house. She reported that the rectangular area, I'm just going to call it A, equals 180 square feet. And her perimeter is 54 feet. When she draws a sketch of her living room the next day, she realized she'd forgotten to write down the dimensions of the room. What are the dimensions of Carla's living room in feet?
It'd be 12 by 15.
All right. Which way did you attack it first?
I kind of attacked it by perimeter.
Okay. So, I'm not saying it's wrong because I don't know. I haven't finished this one yet. But just to double check, were there any others that worked for perimeter?
The first two. Wait, for perimeter.
For
No,
perimeter.
Sorry, I was thinking area. The one below 12 by 15.
The 14 by 13?
Yeah.
That one worked for perimeter too.
And
But
I think yeah, and 16 by 11.
okay, because like I was about to say, these two both work for the area,
Yeah.
but not the perimeter. And so these two work for the perimeter. This is the only one that works for all of them. So I actually agree with your method here. You can solve this with like variables, 2 equations, 2 unknowns, but that's going to take longer. It is easier to just plug in numbers and guess and double check. The only thing to be aware of is to make sure that it works for both, because it's easy to say, oh look, that one worked for area, and move on. And so as long as you are doing the check the answers thing, which is a completely valid strategy, make sure you're doing all the pieces. And so good job. Thank you. All right. We have about 10 minutes left, so we're doing good. Okay. A line contains the point A, B, C, and D. And it tells us that B is between the points A and C. So B is between. And D is between the points C and B. So D is here. We're no longer going in alphabetical order. which of the following inequalities must be true about the lengths of these segments? And so we have BC compared to AB. And it's saying that BC is smaller. Is there any reason for that to be true? No. What we've got is a line, but it's squishy. As long as these two stay in their relative positions, B could be clear over here. And so that one's no good. BD compared to AB. And they're saying BD has to be smaller. AB is here, BD is there. Again, B is squishy. We can move it anywhere we want. There's nothing that says that has to be smaller. BD is smaller than CD. Again, D is squishy. It can go anywhere it wants. CD is smaller than AB. Nope. Again, AB could be here and CD could be shoved over in the corner. Hope this last one works. CD is smaller than BC. Well, yes, because here BC is this greater, CD is a fraction of that. And so it's one, being able to put them in order, and I kind of did that for you because I don't have the book that I can say, look at this problem. But it's just a matter of working through and realizing your drawing is not set in stone. Being able to say, no, just because it's like this when I drew it, there's no rules. All you can do is flex within the rules they gave you. And so that's geometry number sense. All right. This one is a bit more of a regular problem, and so I'm going to have you guys work on this one for a few minutes after I put it on the board, just as a final hurrah challenge. So, we're graphed in the same XY coordinate plane. And we have a circle and a parabola. It's getting worse. So, the circle has a radius equal to 3. And it is centered at 0, 0. The parabola has a vertex at -3, -2, and it passes through the point -2, -1. The circle and the parabola intersect How many times? Do they not meet at all? Do they meet once and only once? Do they meet twice? Do they meet 3 times? 4? How many times do they meet? And again, your options are 0, 1, 2, 3, or 4. All right. So, first question. You don't have to be confident 100%. If this were the bell is about to ring, they're about to say put your pencils down, whatever, we're down to the wire, what would your gut instinct guess be?
2.
Okay? It's a good start. Radius of 3, centered at 0, means it's going to be crossing at 3, negative 3, 3, negative 3. Here's our circle. Our parabola has a vertex at negative 3, negative 2. What do we know about parabolas? Vertex means they're symmetrical. So this has a point also at negative 2, negative 1. So we are going to be going here and here. I agree to 2. It does not have to be beautiful. It does not have to be perfect. All you have to do is be familiar with, okay, this is the general setup. And my drawing's probably not perfect, probably closer to that, but since it's in line with the 3, we know it's not crossing the circle, and we go from there. All right. We are done. Good luck. I assume a lot of you, if you're still here in class after the test, means that you will be taking this again in the future. And I wish you very well. Other than that, I hope you take some of what we do in here into your regular math class, because the more you can just understand what's going on, math fits together like a giant jigsaw puzzle. And so I wish you well.